So the first question here, I gave you a picture depicting an atom, and you had to just use these words to label things. So I'm not going to be too particular on where these first few words go, just because there's no color here really, and even then it would be kind of arbitrary. So essentially what I'm looking for is that in the center here we have a proton and our neutron's nucleus. And this one is your electron. Yeah, to fill in the table with some isotopes, I do want to point out that the key word here is neutral. And what that tells me is that the number of protons and electrons are equal. So we can say the number of protons is equal to the number of electrons. And we need to know that because if they weren't equal, we wouldn't be able to answer this one. Since these are isotopes, their electron count should be the same, and the number of protons should be the same. And then we need to go ahead and do a little bit of math here to name it. But first things first, we need to identify which element it is. So you go ahead and take a look at the periodic table. Element 55 is cesium. And to get the full name, we need the mass number. So what is the mass number on the first one? 168. You just add the protons and neutrons together, so 168. And then next one is also cesium, and 166. All right, similar over here. These are all the same, so 32. These are pairs of isotopes. So then you take a look at what element 32 is. On the periodic table, looks like it's germanium. I wonder where this element was discovered at. All right, and add these two together. Mass number 62, and same element, germanium, and 64. I know I didn't give you much space to write there, so if you just put the element name dash mass number, I'll give you credit for that. Or if you did it the other way, where we put the mass number up and then the symbol, just because of how limited the space was there. All right, the next one here, the key word for this one is that they are non-zero charges. So here I'm basically looking for common charges, and we can use information here to figure things out. All right, and then I went ahead and wrote in the first ones for you so you see what I want. All right, sulfur, so then you take a look at where it's at on the table. Sulfur is a nonmetal, and it's 2 over from the noble gases. So that gives it a common charge of a -2. Once again, sulfur here is element number 16. And if we have a 2- charge, that means we have 2 more electrons than protons. So 18. All right, here a proton, that tells us what element it is. So it's element number 1, which is hydrogen. Hydrogen, being in the first row, has a common charge of a +1, and recall that hydrogen ions have 0 electrons, and they're typically referred to as a proton for short. All right, nitrogen. So nitrogen is also a nonmetal here. It is in the 5th row, which is 3 over from the noble gases. So that gives it a common charge of 3-. And then element number 7. And then we should have 3 more of the electrons and protons due to the minus charge, so that gives us 10. All right, and then similar to the hydrogen problem, we have to use that number to figure out which element it is. So calcium is element number 20 from the proton number, and calcium is in the 2nd column rather. Remember that when you're dealing on this side of the table, we get positives. On this side of the table, we get negatives. So then we need 2 less electrons, 18. So the first one here, we can use the cross method to get the charge. We can't just look at the periodic table, because if you look at iron on the table, it's here in the middle, right here, which means it's one of the ones that can have a variable charge. So I'm going to use the bromines here to figure that out. So I know that bromine, based on its position, is a -1. So I can go ahead and put that in here. Br- So that means that iron must be a 3+. And we have to denote that in the name. So this is iron 3 bromide. Both of these here were different polyatomic ions. So I think when you're working with the name, you should work backwards. We get the cation, anion first, then get the compound. So ammonium is NH4 with a plus. Carbonate is a CO3 2-. And then notice when I put them together, their charges don't match. So I need 2 ammoniums per 1 carbonate. So NH4, 2, CO3. All right, next one here, sodium acetate. Sodium is Na+1. And I got that charge just based off of where it is in the table. It's in the first column. And then acetate is C2H3O2 with the -1. So we have 1 of each. So then we get nacho, right? You can use that to remember what the ion is. All right, moving along here. So now we're going back the other way again. So I know that hydroxide is a -1. So that means that the copper must be a 2+. And similar to the iron, copper is one of the ones in the middle of the table, has a variable charge. So we have to put that in the name. So copper 2 hydroxide. All right, here we have aluminum hydroxide. Aluminum is here. So that gives it a charge of +3. So Al3+, and then hydroxide is OH-. So it looks like we're going to need 3 hydroxides per 1 aluminum. So Al parenthesis OH close parenthesis 3. All right, next one here, we're kind of starting in the middle where we're given the ions. You got to get the compound and the name. So notice we have a +2 and a -2, so we need 1 of each. Remember that if you're doing the cross method and you end up with the same number on both of the cation and the anion, just reduce it to its common factor here. Just reduce it by 2. So this is barium. Barium is a main group element, so we don't have to denote the charge. And that anion is sulfate. All right. Next here I gave you an acid. Remember that acids are named by whatever anion there is. So if it says acid, we automatically know that the cation is an H+. And ic acid comes from 8. So we have iodate. This is IO3 -1. And then putting them together, HiO3. All right, next one here. You may notice that we have phosphorus and bromine. And if you look at the periodic table, you may notice that they're both nonmetals, and they're all on the right side of the table. So these don't have cations and anions. This is a molecular compound. And you name it as such. So phosphorus. And then we have 3 bromines, so tribromide. All right, next one here, +1, -1, so we just need 1 of each. And then we have the name, sodium. That is a 2 there for the oxygens. Nitrate is NO3, so we have 1 less, making it nitrate. All right, next one here, potassium permanganate. So we have K+, and MnO4-. So this is KMnO4. I also want to point out here that when you work with permanganate in the real world, this is actually the most common way you're going to see it, is potassium permanganate. Nice purple liquid when you have it dissolved. It's actually pretty cool. So when you have the solid, it's a kind of like a palish blue color. As soon as you put it into water, it becomes a really dark, vibrant purple. It's pretty cool. You got to play with that stuff in lab, in Chem 121 and 122, and hopefully don't get any on your clothes because it'll eat through your clothing. So, just random side notes there for you. All right, number 5 here. So this one you had to calculate the molecular weight, and I gave you some masses here and percent abundances, and then masses here on AMU. So what we need to do is, well, first things first, I wanted to point out that, remember, this is a weighted average. So whatever our answer comes out to be, it should be closest to this one. And the reason why is because that's the one that's the most abundant. It's going to work out in your math where it should be really close to whichever one is the most abundant. If they're, say, 50-50, it'll land somewhere in the middle. Remember, it's weighted average. So here I'm just going to write out all the units. So 27.976927, the units are AMU. Multiply it by the percent abundance as a fraction. So we move the decimal over to make it a fraction, so it becomes 0.9223. There's no unit on a fraction. And just repeat that for all the other ones. So 28.976495 AMU. And then here 0.0467. Plus the last one, 29.973770 AMU times the fraction, like so. And then I recommend when you're working with this in your calculator just to do it all at once, punching each multiplication at a time. So let's go ahead and take a look how this works out. 27.976927 times the 0.9223. I get that. And then plus 28.976495 times 0.0467. We get that. So we're getting closer and closer to the actual value. So 29.973770 times 0.031. All right, and notice how it's just like I said, it's really close to this value here. And the question states to 4 significant figures, so my final answer will be 28.0, should I just put 8 there? 9, right? You got to round up. And the units are AMU. All right. The next question here is, what is that element? So then you go ahead and take a look at the periodic table and look at the one that has the closest mass that matches, and it looks like it's silicon. So all right, and that is quiz number 3.